Good morning, everyone. How are we doing after the weekend? Good, bad, indifferent? Sophia. Can you type in the chat for me? Just say hello. Yeah, I had a great weekend, something like that, real quick, so I know that you are not sleeping over there. Hello, thank you. I'll take that. Good morning. I take that too. Well, we'll wait for everybody to kind of come on in before we get started. While we're waiting, just take a second to think about my daily word, my word of the day. Hello, Isaiah. My word of the day is integrity. So as people are filtering in, if people filter in, hopefully, think about why integrity is important and think of an example of something you did that shows integrity. Take a few minutes, think about it. We'll see who's going to show up. Last few times it's just been Sophia. So Isaiah, welcome. Let's see. I'm thinking. So integrity, the true meaning of integrity is the unwavering commitment to one's strong moral and ethical principles, characterized by honesty, truthfulness, and a consistent adherence to what is right. Let's see. Sophia says integrity is important because without it, nothing could be taken as true. Oh, I like that. And you wouldn't be able to trust anyone. I always tell the truth, even if it gets me into trouble. I love that. I love that. I'm going to respond as well. Thank you, Sophia. Isaiah, you going to play along with us? That's why I think integrity is important because it tells someone's true character. Very similar to what Sophia was getting at. It's hard to trust anyone, put your trust in someone if they don't have integrity. Give an example of something you did that shows integrity. Let's see. Isaiah, integrity is important because that helps you build a good community where you can trust and shake hands with all your neighbors. Oh, I love that. Keeping practice organized with my head when your head coach was gone. That is awesome. I'm gonna give you a clap for that one. Very, very good. Let's see. Let's see. Hmm, this is a hard one. Okay, that's my example. It took me a second to come up with one. It's kind of it's kind of tough to think about. You just kind of do things that show integrity all day long on a constant basis, and it's hard to nail it down. Okay, so this is us right here. I'm going to show you a very quick video since Unit 3 is jumping into periodic table of elements. And then what I want to go over is I want to go over the elemental investigation, which is slotted for today if you look on the schedule. So if you're a little bit behind, you will not have quite gotten here, or it might be a few days till you get here. Or if you're right on track in Bright Thinker, then this is actually on your to-do list today. The elemental investigation. You do need a calculator. So I'm going to show you a quick video over the periodic table of elements, one that I really like to kind of kick us off, and then we'll work through that one together. Oh, gotta make sure I turn the volume on. Okay, here we go. Very quick, 4-minute video. Periodic table.
The periodic table is instantly recognizable. It's not just in every chemistry lab worldwide. It's found on t-shirts, coffee mugs, and shower curtains. But the periodic table isn't just another trendy icon. It's a massive slab of human genius, up there with the Taj Mahal, the Mona Lisa, and the ice cream sandwich. And the table's creator, Dmitry Mendeleev, is a bona fide Science Hall of Famer. But why? What's so great about him and his table? Is it because he made a comprehensive list of the known elements? Nah, you don't earn a spot in Science Valhalla just for making a list. Besides, Mendeleev was far from the first person to do that. Is it because Mendeleev arranged elements with similar properties together? Not really, that had already been done too. So what was Mendeleev's genius? Let's look at one of the first versions of the periodic table from around 1870. Here we see elements designated by their two-letter symbols arranged in a table. Check out the entry at the third column, fifth row. There's a dash there. From that unassuming placeholder springs the raw brilliance of Mendeleev. That dash is science. By putting that dash there, Dmitry was making a bold statement. He said, and I'm paraphrasing here, "Y'all haven't discovered this element yet. In the meantime, I'm going to give it a name. It's one step away from aluminum, so we'll call it Eka aluminum. Eka being Sanskrit for one. Nobody's found Eka aluminum yet, so we don't know anything about it, right? Wrong. Based on where it's located, I can tell you all about it. First of all, an atom of Eka aluminum has an atomic weight of 68, about 68 times heavier than a hydrogen atom. When Eka aluminum is isolated, you'll see it's a solid metal at room temperature. It's shiny, it conducts heat really well, it can be flattened into a sheet, stretched into a wire, but its melting point is low, like freakishly low. Oh, and a cubic centimeter of it will weigh 6 grams. Mendeleev could predict all of these things simply from where the blank spot was and his understanding of how the elements surrounding it behaved. A few years after this prediction, a French guy named Paul-Émile Lecoq de Bois-Baudran discovered a new element in ore samples and named it gallium after Gaul, the historical name for France. Gallium is one step away from aluminum on the periodic table. It's Eka aluminum. So were Mendeleev's predictions right? Gallium's atomic weight is 69.72. A cubic centimeter of it weighs 5.9 grams. It's a solid metal at room temperature, but it melts at a paltry 30 degrees Celsius, 85 degrees Fahrenheit. It melts in your mouth and in your hand. Not only did Mendeleev completely nail gallium, he predicted other elements that were unknown at the time: scandium, germanium, rhenium. The element he called Eka manganese is now called technetium. Technetium is so rare it couldn't be isolated until it was synthesized in a cyclotron in 1937, almost 70 years after Dmitry predicted its existence, 30 years after he died. Dmitry died without a Nobel Prize in 1907, but he wound up receiving a much more exclusive honor. In 1955, scientists at UC Berkeley successfully created 17 atoms of a previously undiscovered element. This element filled an empty spot in the periodic table at number 101 and was officially named Mendelevium in 1963. There have been well over 800 Nobel Prize winners, but only 15 scientists have an element named after them. So the next time you stare at a periodic table, whether it's on the wall of a university classroom or on a $5 coffee mug, Dmitry Mendeleev, the architect of the periodic table, will be staring back.
I think that kind of is perfect considering we're just kicking off the periodic table of elements. This is what I decided for this week. If you are to look on, let me see if I can pull it up. I just literally pulled it up right here. back to where I need to get back to. Okay, so like I said, today I wanted to kind of help you guys through the elemental investigation. Can you put in the chat, have either one of you gotten to this point yet? Have you already done this assignment? This is what it looks like, an elemental investigation. You can just throw that into the chat. Let me know whether you've gotten to it or not, because I wanted to work through it today. And then what I wanted to do was just kind of back up a little. So today we're in unit 3. Today we're right around here. So like today you were supposed to, these are the things that are on your to-do list. So I think the video kind of covers lesson 4. I wanted to do this one together, and then to Wednesday, I'm going to back up and I'm really going to talk about this lesson right here, to get things clarified. No. Isaiah, have you done that lesson yet? Okay, I'm going to share my screen. So first of all, here is our periodic table of elements. There's a few things I want to talk about. As I'm chatting, please make sure that you grab yourself a calculator, either your own calculator, like if you have an old school calculator like this, or just open another tab and just pull up the calculator. It doesn't have to be a scientific calculator, but we do need some averages. So just a few kind of basic things. The periodic table is set up in groups and in periods. So our groups, whoa, let me try and do this so I don't, there we go. So our columns are called groups or families. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 groups. So the columns are referred to as groups or families. A lot of times they're called families, or people like to refer to them as families because the elements in the same group or family have very similar chemical and physical properties. And that's because of how many electrons they have on their last energy level. So all of the elements in group 1 have 1 electron on their last energy level. And that the electrons found on the last energy level, they're called valence electrons. That's not working. Not working at all. There we go. That's what I was looking for. Okay, let's get back to what I was doing here. Okay, so we have 18 groups on the periodic table or families, and we have 7 periods. The rows on the periodic table are called periods. They're not called rows. So we have first one right here, 1. So this is the first period. This is the second period. This is the third period, all the way down to the 7th period. Okay, see if I can get rid of some of these. Get rid of that guy. There we go. Okay, these guys right here fit into the periodic table. Okay, these are called the lanthanides and the actinides, and they actually fit right in here. They took them out of the periodic table only because they made the periodic table way too long. And so it's just easier to put the periodic table on one sheet of paper if we take the lanthanides and the actinides and we kick them off the island and put them down here. Okay, so these guys are actually found in period 6 and period 7. Okay, so for this activity, what you definitely need to know is all of the elements in one group are going to have very similar chemical and physical properties, as in rust easily, or they might be solid at room temperature, or they might not rust easily. They might not combine with oxygen very easily. They could be very reactive when they get in contact with water or the air. These are all chemical and physical properties. So all the elements in a group like this are going to have very similar chemical and physical properties. We got to keep that in mind. Okay. Can you give me a thumbs up or put it in the chat. Thumbs up or in the chat if you have a calculator handy near you. In a different tab. Okay, cool. Okay, so I'm going to get this started for you. I mean, we have about 10 minutes. So I'm going to get this started, and if we don't finish it together, it will get you rolling. And you can either do one of two things. If you have paper and pencil handy next to you, great. If you want to pull up a document, like just a Word document or a PowerPoint, and use your stylus, I'm going to walk you guys through this. Okay, so here is the activity. It says you are on the quest to find two elements, element A and element B. Okay, so we have two unknown elements, element A and element B. By using their properties, so you're on the quest to find two elements, A and B, by using their properties, chemical and physical. Using the periodic table, use these clues to determine the elements. Okay, so element A is located in group 14. So here's group 14. Oops, I'm going to change my colors to stay consistent. Okay, so here's group 14 right here. I'm going to get rid of down here. Okay, so group 14, geez, my handwriting is terrible. Let's try that again. Group 14 right here. And group 16, B is in group 16, so it's going to be in that group right there. Element A is okay. Here is some property information about elements near element A. Okay, so here's element A. So around element A, we have arsenic, which has this density, this melting point, and that atomic radius. They give us tin. So they give us the information for tin and for gallium. And then for B, element B, they give us some information properties for elements that are around element B. So element A, I'm going to use red. So the elements that are around element A are arsenic, tin, arsenic, tin, and gallium. And then elements around element B are bromine, tellurium, and arsenic. So we need to use these properties, and we are going to try to use these properties to find out what our unknown elements are. Okay. So here, number 4, this is where all the work comes in. It says average the density, melting point, and atomic radius for the values of the elements near A and near B. That's this information right here. Compare the averages with these tables right here. So I am going to, let me see if I can I'm going to take this guy. I'm going to pull him over here. There we go. Okay. I'm going to get my blank sheet of paper. We are going to find the average. Okay. We are going to find the average of all of these densities, all of these melting points, and all of these atomic radii. And then we're going to do the same thing for element B, average, average, average. And then we're going to take those averages and we're going to see where they closest match up in the first table and the second table. So I'm going to start right here. So I'm going to start with density. So this is going to be element A. So we have 5.72 plus 7.3 plus 5.89. I'm going to write it all out and then we're going to do the math. Again, this is all element A. Melting point, 1090, 505, 303. And atomic radius, we've got 114, 140, and 136. Now, if you guys remember, when you average something, you add all the values together and divide by how many of those values you have. So 5.72 plus 7.3 plus 5.89, and then I'm going to divide it by 3, should give me 6.30, and that's my density. My melting point, 1090 plus 505 plus 303 divided by 3 gives me 633. Atomic radius, 114 plus 140 plus 136 divided by 3. Oh, let's try that again. 114 plus 140 plus 136 divided by 3 is going to give me, is my numbers right? 114 plus 140 plus 136 divided by 3. Oh, there we go. Gives me 130. Okay, that is element A. So now I'm going to do my math for element B, and I'm just going to do it down here. Density. So we have density. So we have 3.1 plus 6.24 plus 5.72. And then melting point, we've got 266 plus 723 plus 1090. And our atomic radius, we've got 119 plus 138.3 plus 114. We're going to do the same thing. We're going to average all of those, and I'm kind of running out of room a little bit, so I'm going to have to be creative. 3.1 plus 6.24 plus 5.72 divided by 3 would give me density 5.02. This one's a little less dense. So 266 plus 723 plus 1090 divided by 3 is going to give us 693. And then 119 plus 138.3 plus 114 divided by 3 is 124. Now, if my math is bad and you catch me doing, having a incorrect answer or something like that, just holler at me. Okay, so now our job is to do this. Our job is to figure out what the unknown elements are using our averages. So I am going to, let's see, 6.30 for A, 633 and 130. So I'm gonna pull this guy down here. We're gonna take a look at, see if I can, there we go. Okay. So we had 633, or sorry, 6.3. I'm looking at element A right now. We want to try and figure out using this chart. Is it carbon, silicon, germanium, tin, or lead? So we want to take our averages. So our density, okay, that we calculated was I don't know if it'll let me write on here, was 6.3. Just do this. That way I can write on it. Okay, so our density we calculated was 6. Goodness, 6.3. Our melting point was 633, and our atomic radius was 130. So let's tackle group A first. So this was 6.3. So the closest to 6.3, that's not spot on because we're averaging all of the elements around it. But I would say the closest, somewhere 5.23. So I would say it's closer probably to 5.23. 633, geez. That might fall somewhere, well, somewhere in between here, I would say. And then 130 is going to fall somewhere in between here. So since our values are super close to, okay, right now I'm going to put a question mark here. I'm going to do the same thing in the next, I'm going to do the same thing in the next group or in the next chart. And then we're going to use this information to try and help us determine what element is what. So density, and I know it's just a little over time. I'm going to let you guys go in a second. And then this will give you a good idea of how to finish this assignment. You won't have much left to do. 5.02 is right in between here. 693, I'd say right in between here. 124, right in between here. So these could be selenium or tellurium. And then this one to me looks pretty darn close to germanium. So element A got its name because the scientists wanted an element named similar to the country Germany. Gray in color, it is a great semiconductor. That means it's like a metalloid. May be found in items such as your camera lens or fluorescent lamp. So for this one right up here, it's got his name from Germany, and our averages are all right kind of in between germanium and tin. What do you guys think? Do you think it's safe to guess that element A is probably germanium? I got a thumbs up from Sophia. So the next one, element B, let's see what it gives us here. Element B is a very versatile element named after the moon. This element is found in items such as solar panels, red color in glass, and even a photocopy machine. So I would say with our averages, it's got to be either selenium or tellurium. What would you guys guess? I think since we've got 2 of the 3 values that are closest to selenium, I mean, I'm gonna guess that it is selenium. Can I get a thumbs up, a thumbs down, or I completely disagree with you? I got a thumbs up. Okay. So that means what you guys are left to do on this assignment, because we've done all the math, right? We've done all that math. So if you want to take a picture real quick here, take a screenshot to make sure you've got all the math. So when you are ready to turn this in, you can do the math yourself and it will be correct because we've done it together. And then you'll have questions 1, 2, and 3 to answer as well. So we did 4 together. So you'll have all the correct information for 4 when you turn this in. We did number 1 together. So you'll need to answer 2 and 3 just by yourself when you turn this one in. What do you think? That wasn't too bad, right? Was that pretty good? I got a thumbs up. Okay, cool. So next time on Wednesday, I am going to talk, I'm going to do a lesson over isotopes, over ions, cations, anions, and kind of explain several of the things, lessons before this lesson. Do you guys have any questions? I know we're 6 minutes over, so I want to let you guys go. Any questions? Okay. I'll take your silence as no, I totally get it. Okay, I'm gonna let you guys go. I have your took attendance. I've got you guys marked down for your extra credit, and I hope you guys have a wonderful day. Happy Monday. Thank you. Have a good day too.